All right, I guess we should consider getting started. Are you ready down there? Okay. So I did not expect anybody to show up at the last time slot to talk about Rust procedural macros. That's a brave choice. You are warned. You can go to the other one if you feel like relaxing. So you will see in the title, it's a not so deep talk about Rust procedural macros and making a custom domain-specific language, because I will try to not go into the weeds of the details since we kind of don't have infinite time. A little bit about me. I'm Mathias. I have a very small YouTube channel that you definitely haven't seen because I try to run it in the least algorithm-friendly way possible. My day job, I work as a staff engineer at Appear at Lysaker. We make hardware for TV contribution and also software solutions. And sometimes I forge knives in my garage. What is Grov, since you have the logo there, you may ask? And that's a company I started to basically make my own grow lights because you, for some reason, cannot order custom aluminum extrusions from Hydro as a private citizen, so we needed a company. And then after that, my police friend visited me a lot more. So that was nice. And non-goals for this task. We will, as I said, not go into the details of proc macros because we don't have time. It's an enormous topic by itself. It's not, as you may expect it to be, a end-all, be-all discussion about JSON RPC details and providing you with an actual implementation of anything, because it's not really the point. We will showcase a little bit simplistically how you can make a DSL to work with this, but it's not meant to be the final answer. And I'm not here to teach you Rust. Just a show of hands, who has written Rust here before? Okay. Who has written a proc macro before? Okay, you guys may not have that much to gain from it. The rest of you are kind of, if you don't follow the details, just nod along and be happy that it's soon over. Let's get started. So, the dark arts of procedural macros in Rust. And it's basically a function that you write in normal Rust code. You can see an example of one here. That runs at compile time. And then the input to the function is a token stream in this case, which is just yanked out of your source code text and passed into this function. And the output is a token stream, so you can transform that input text to a different output text. As you can see here, we take the input token stream and we add this new function declaration in front of it, and then we include the original input token stream as well in that generated stream here. You typically use the syn and quote craze to help here. Otherwise, you will have to write your own Rust parser, which isn't something you should do. And also for generating Rust output, the quote crate is very useful to avoid having to just combine a lot of text that's in your code. And there are three types of procedural macros. There's function-like, which is what we will be talking about today. There's attribute macros and derive macros. You probably know derive macros the best. And as Yoda said, always three there are. Interestingly, the AI got the number of fingers correct. So they have 3 fingers. But the quote is originally always 2 there are. So it's a funny thing how it manages to understand the world. And macro invocation happens like this. You call this function like macro, and this block here is then the input token stream that we saw in the previous example. And that expands at compile time into this output here. So you can see it added this function, and then our function that we originally passed into the macro is added at the end, which calls the generated function. And all of this is resolved at compile time, so that you get compile errors if you do something wrong. You may have seen a lot of these exclamation marks in Rust, and here's a little bit of a highlight as to why. This sneaky macro takes a string literal as input, which is fine, that's okay. But it can insert both hidden control flow and the panic. Like, you don't see this from reading this piece of code text here without expanding the macro and seeing what it actually resolves to at compile time. So the exclamation mark is there just to tell you, oops, hey, here is something that you should consider taking a deeper look at to understand that there's danger there. Because you really don't want to inject random control flow in your program. That's not a good thing. And the language part of this is essentially that inside of the procedural macro, since we're parsing the token stream, we can declare our own grammars and create a language that macro accepts. And in this case, we're making a very simple language that has one keyword, which is reverse, and a string literal that follows it, right? So that's the syntax of our very simple language. To do that, you write basically a parser, and in this case, I made it into a struct with an impl parse. You can see it basically takes out of the token stream a keyword, which we define to be reverse, and the string literal. And that value we get for the string literal here contains reference to where in the code it's originating, but also more importantly, the actual value of the string literal as you see it in your program text here. And then in the implementation of the macro, we simply parse or attempt to parse our reverse struct out of the token stream. So if it gets a token stream that doesn't contain the correct syntax, it will fail at compile time. If it succeeds, we get to literal, ignoring the keyword because it's just there to facilitate the grammar. We reverse it and output that string literal in the token. So this all happens at compile time. It just yanks your original code out of the program text and then replaces it with the output of this operation here. And as you can see here, the expansion at compile time goes into hello world, right? And any questions about that so far? No. And then JSON RPC, really? It's probably the question a lot of you ask. It's not that popular. It's mostly used by crypto bros, the Bevy game engine, which is the nice little bird here. A few AI-related protocols, most famously MCPs. Also the new ACP uses JSON RPC. Appear, and a lot of the concepts in the following language is applicable to anything really, any API declaration you will want. You can easily do REST, but we're doing JSON RPC currently. So the basics of JSON RPC is it's a relatively simple RPC protocol. It has, as the name suggests, a JSON envelope. So you pass in a request. You have to provide an ID. This is for matching the response. If you do a batch call, you need to be able to match a concrete response to a concrete request, essentially. And then it has the name of the method you're invoking and the parameters to the function. And this is a user-defined type. It can be any valid JSON. Similarly, the response is just the result. We ignore errors, as always. Who cares about error handling? It's unimportant. There are some drawbacks to the protocol itself if you're doing web scale stuff. Primarily that if you want to dispatch or do anything with the method before actually receiving the full body, you cannot do that at least in a robust fashion, since you have to receive the whole JSON text and parse it to be able to see which method is being called, for instance. So it's a bit, there's a higher overhead if you're doing dispatch to different handlers or different services based on the message. In that case, REST is better. But in many cases, you don't call. If you're just doing service to service on the back end, you don't have that many clients calling, so you're okay with this. And before we get into the macro world, the normal approach to writing a JSON RPC backend service would be something like this. You would have a library providing a JSON RPC service builder or a way of constructing them. You would register your methods with a name and some handlers. Notice this is still typed. It's a Serde type that is just expecting any value that's basically asserted deserialized in this case. And it returns a value. That's it. Very simple, straightforward code. What's wrong with the normal approach? Absolutely nothing. You should do normal. Now, thanks for coming and have a nice lock note. But we have to make a language for this because the title of the talk says that we have to. And also a little bit because it's fun. and a bit crazy, but yeah. A little bit of a sidetrack and warning here. I have been down pathways before attempting to solve a similar problem that ended in us implementing a general purpose programming language. And it's not recommended. That's never the answer. However, if you make a specific language to express this, to declare your API and sort of create a type-safe environment, you can simplify a lot of things by removing all the boilerplate REST code. And it's easier to express the problem of your domain in a simpler language that then generates code. It's basically code gen. And it can also highlight a couple of things that are problematic if they're spread out amongst a lot of boilerplate code. So if you're missing authorization, for instance, you would want to easily see which method is missing authorization. But if that's spread in like 50 calls to library code, you don't really, it's not that visible. So having a denser, more purpose-built DSL helps in sort of identifying problems in the domain. And in this case, the problem would be my method doesn't have auth compared to normal code. We also get, since this all compiles down to code that is in turn compiled by the Rust compiler, we get compile errors if we make mistakes in our domain. So if we have some fault there, it will just simply not compile. And yeah, it can reduce boilerplate quite a lot. The drawbacks is that it adds a level of indirection between your program code and the code actually running to serve your function. So it can be harder to debug and sort of, maybe not debug, but to understand what's happening, especially for juniors coming in that aren't that familiar with macros and how to sort of peek behind the curtain. And if your domain can change a lot, or your DSL is imprecise to begin with, it's a big maintenance burden to go and change the proc macro, because they're fun to write, but they can be painful to revisit if you don't remember exactly what's going on, because the code can get quite complex. And then we can talk about sketching up a small language to use for this API JSON RPC definition. It would be nice if it resembled how you would write a struct definition in Rust loosely, because essentially we're making a declaration of an API to an object-like entity, which is a service, an API service that you would be hosting, for instance. And when we do define methods, they're pretty much functions, right? They're normal Rust functions. So the syntax should be similar to how you would define functions in a trait or on a struct implementation. But we do want to be very explicit about permission or auth in this case. That's important to the domain of an RPC service, right? You care about who's allowed to call this function and who isn't, more importantly. So let's say we want to use the unauthorized keyword to highly make it visible that this function requires no auth to call. If you can reach the port of this API, you can call this function, is what that means. It's kind of on the same lines of unsafe, right, in Rust. If you have an unsafe block, you need to pay attention to it and make sure there isn't any risk inside of that block. It's a little bit the same for a method declared as unauthorized, because it really means anybody can call it in this imaginary language we're making. And you also want to be clear about the requirements in the case where you have authorization for it. So in this case, we're introducing the with permissions keyword, and then you give it a list of permissions that a token used to access the method must have in order to invoke the method. So in the text of the program, you would be able to read what are the permissions required to invoke this method. And then when you're starting to implement this or playing around with the thought, it's useful to just write down something like this, where it's just an example of how you would ideally want to use it. And you sketch out the syntax. Of course, I cheated here and I knew what it would look like before I started writing this example, but in the real world, you would sit down and sort of play around with this, figure out what feels right, how do I express things in my domain, and you would come up with the syntax that you would use to describe this. So you see, we're just passing this block into the proc macro, and then internally we'll have to parse this and turn it into actual Rust code that sets up everything you wanted to generate. But we can already see what we talked about in the previous slide here, that you have typed methods. So this looks like a normal Rust function-ish, request type, response type. Login is unauthorized because it has to be. And for this create post, you need the post create permission. You can read this by just looking at this language. You don't need to go to any handler registration function, or it's not spread out anywhere. It's just in the definition of your service. You have all the information you need to make important decisions and analyze this API. And what should it produce? So you would want to transform this syntax into some actual Rust code. And in the cases we've done, it basically creates a tower service. Anybody familiar with the Axiom Tower Hyper kind of stack in Rust? Yeah. So it produces basically normal middleware there, which gives you something that you can mix with other layers if you want to. And in this example, it does it by using a builder. It's a typed builder, but you provide handlers for your methods that you declared, and you can see here for the authorized method, it gets passed in a argument, which is that authorized user in this case. So that is extracted by the middleware and just injected as a typed parameter to your callback function. And the types are strong in this one. So since the methods have essentially uniquely generated type signatures per method, there's really no way to mess this up. Like when you're registering your handler, you don't make a choice at this point. The compiler will yell at you if you give it the wrong handler signature. And also, you could imagine having a syntax where you ask to get the HTTP headers associated with this request as a raw reference to that, for instance, if you wanted to peek into it. And in some cases, you may not want that. And that would all be typed and enforced at build time. The builder is, of course, just a choice. That's a choice you make when you create the macro. So you could generate this as a trait that you would implement for your service. And then you essentially, when you build your API here, you just say with service, and you provide the implementation of that trait for it to delegate calls to when it gets an RPC method invocation. I skipped over the URL, but that's just the base URL for that endpoint that you're creating for the service in the Axiom world. And in this imaginary example, if one or more methods require authentication, you can actually enforce that you must give it a way of accessing or validating tokens. So in this case, we call it auth provider. This would be an implementation of a trait that you create to validate your token, typically with a certificate check. And the builder can also be compile time safe. So in this case, it's a runtime check that you have provided all the methods. It's a bit simpler to make. But you could also then use the type state builder pattern to actually make this build method inaccessible at compile time if you haven't given it the correct properties. So it would fail at compile time if you in this case, you have provided neither create post nor auth provider. And then this build method just literally does not exist on that builder struct, so you would get the compile time error. And the macro can generate type state builders for your specific service case, so that's very strong compile time checking for us there. And then the client is always right, at least they claim to be. So since we have full control over the code we generate, we can also create proxy clients. It's basically traits and implementations for a client of this API that would typically use request or some way of accessing it over HTTP. But it exposes strongly typed functions on the client side. So if you call a method as a normal async method here on the client object, you know that matches the type signature of your backend, right? There's no discrepancy between them. It's just a direct one-to-one mapping between those two. And you know the methods will be there. They will be implemented because of the compile time constraint. This is obviously not true for all ways of deploying software, but in the case where you have a front end coupled to your backend or two services talking together in the same sort of application deployment environment, most likely you can enforce that they will match, right? And since it's all Rust code, the only thing you really do is depend on that API crate directly as a cargo dependency. You should use feature flags so that you don't force the client to build the server, and vice versa. You can sort of enable by selectively saying client and server features enabled, what you get when you depend on the crate. And of course, you can also then generate OpenAPI and OpenRPC definition files, which are just JSON objects describing an API. I'm sure people have heard about OpenAPI. The only thing you really enforce then is that the types that you give, sort of request response types, are schema.rs compatible, or whatever you choose to represent your schema, but in most cases you want schema.rs. And that lets the macro generate code that assumes that trait is implemented for those types and generates the OpenAPI schema just by calling .toSchema on the types. And again, if that type you give it doesn't implement the toJSON schema trait, that will fail compile time, and it will tell you you need to implement this trait or this function to be able to use this type. That's normally a runtime thing, so you need to generate the schema either as part of your server hosting or in a test, because it's a bit tricky to do this actually at compile time. And then, of course, you can use those files to generate clients for other frameworks and languages, because they're fairly standard. And while we're on generating clients, you can generate, for instance, an Oxum test client for your backend API, which lets you essentially, in one process, simulate the entire stack, because the Oxum test crates allow you to wrap an Oxum service in basically an in-memory mock of the HTTP layer. So you can make HTTP calls to that server. But then you can also have a test client that accepts a Oxum test server that would make the real fake HTTP calls to your server. And this would just run in one single process, right? There's no network or anything involved. It's just in your test, you fire up the entire stack, including the client and the server in the same process, and just make a call that propagates all the way through the HTTP layers and back, and you can test your server code in the same process as you have the client running. And that allows you to do some interesting tests where you can test for cancel safety, or you manually poll those futures that the client returns, and you have full control from the test perspective what's happening to those futures. And that's useful in some cases. We actually had problems where essentially the future or the task spawned by Oxum for an HTTP request was tied in with the lifetime of an asynchronous operation that should happen in the backend. And when the HTTP call got canceled, it failed and caused some invariants to not hold true, and that was actually a problem. So this would be useful in that case to simulate those cases where you care about this and manually cancel futures so that you could prove that the server still does what it says it should do. And on the little bit more abstract side of things, this allows you to sort of visualize communication patterns in your systems as pure cargo crates. You see, we have this published API crate here that would be implemented by service A, but service B depends on it. And then at compile time, you can see who is actually talking to whom in your system by just looking at the dependencies of these crates. Of course, then you need to make sure you expose all the types needed by the API as well as the service definition. And then we get to the REST. As I said earlier, you can actually quite simply transform this language into supporting REST. So in this case, we basically added all the HTTP verbs and some syntax to support URL and query parameters. And that would compile, in this case, and generate a trait that you implement for your server-side service, which has sort of encoded the path in the name, so get user by ID. That's get user by ID as the parameter here. And again, you would, in a very strongly enforced manner, be told to support all of these query parameters in your backend handler. There is no way to mess this up in this case. Because in the language here, you express these are the query parameters to your method. You must handle them. In this case, it's optional. But you are forced to care about the optionality of that query parameter in your Rust code. And then I realized I blazed through this, but that means it's almost time for going home. I think we should stop focusing on this whole Rust versus C++ thing. It's kind of meaningless. We both need to coexist and focus on the important stuff, which is we need to replace JavaScript instead. And since we like crazy things, we are writing our UI in Rust, as you would for the browser. But the client that we generated up somewhere in the back here, it essentially compiles for WebAssembly, which means our front end just depends on the backend API as a dependency, and then we have in the browser world the perfect proxy for our backend that is type safe, and we use the same types just in the front end application. And that has a nice feeling to it, because when you make a change to a type or an API, your UI code just stops compiling and it points to the line that you changed in the Rust code, essentially, for the backend code. And you can use the IDE to jump between your code files as you would normally do. There's no going into TypeScript, going into the backend code. It's just all one stack. It's super nice to deal with. And to further extend the crazy, I made a small macro that essentially takes a tailwind CSS string, literal. So this would be more or less valid tailwind syntax, if you're familiar with that in the front-end world. It takes that string literal and feeds it into a custom num parser that parses this language inside of the string literal and outputs Rust tokens that insert CSS classes, CSS utility classes at compile time. So all of these fancy media queries, etc. Here, if you mistype that, it fails compile time for your front end, and then it tells you, BG red 990 doesn't exist, you moron. And believe me, if you have worked with styling, this is a real problem. You have typos or make mistakes in CSS, and they are nowhere to be seen. They just silently exist. And this is not a new invention or anything. If you want to play with this, there's JSON RPC and Poem. Both of them support similar. It's a bit hard to see, I guess, but if you go to their GitHub, you can see the examples. They have a similar approach with macros to define your APIs, and you can use that. It's open source. They seem to favor attribute-based annotations instead of the function-like, but it's basically the same idea. You have compile time generation of the server side, everything you need here. So that's you can just go and play with those. And in conclusion, proc macros, they let you invent completely new novel Rust syntax, or not even Rust syntax, it's just some syntax that you can put in your program to express a subset or a problem in your domain that fits your needs. And it can greatly remove a lot of boilerplate code that you would normally write. So a typical web service would have a lot of stuff to set up the handler, set up the auth, set up everything. That's just something you don't see that much of when you use this approach. Instead, you just see the important things, which are which methods are defined and what are the auth requirements to call them. And a word of caution is it is a case of this could we versus should we. You should have a pretty good reason to use a proc macro and make a DSL, because it tends to increase the complexity of your program quite a bit, at least until you stabilize the language and the implementation of the macro, and you don't need to maintain it that much. And of course, Rust should replace JavaScript, because nobody wants to write JavaScript, really. But yeah, the takeaway here shouldn't really be the details of the API definitions here or anything. It's more that idea that you can make your own language without too much hassle. I'm not going to lie. So this example that we saw in the beginning of a proc macro, if we can ever get there. Oh my. This is extremely simplistic, right? It's super simple code. The reason I don't show any of the actual macros for those JSON RPC things we were looking at later is that it's a couple of 1,000 lines of code of just parsing and generating Rust code. And when you start generating Rust code from a parser that you wrote, you get like 4 levels of indirection, and you start messing up and thinking in all crazy ways. So it's really hard to reason about when you're writing this. So there's a clear cognitive cost to implementing a proc macro. But once you have it, it's super nice, and it makes a lot of other things simpler. But just be aware that this explodes in complexity at some point. Especially when you then add a secondary layer of a non-parser that you're sort of pseudo compile time executing as well, and it just, yeah, it gets hard to reason about at some point. But it is nice to get compile time errors for common mistakes, and as long as you can model that domain-specific language so that it represents concrete things in your domain that you care about, that's a great benefit. And yeah, bye. You can find me on YouTube. Any questions? We have time for questions. No? Okay. See ya.